So here we have week 3, question 2, and we're looking at exponential functions and application. So if you have a history of studying business math, financial math, you'll remember that simple interest had interest being added only on the principal, and it grew linearly or at the same rate each year, and it was generally used for short-term loans or short-term investments. So this question looks at compound interest, which is the type of interest earned on the principal and the interest. And so it grew at an exponential rate. So starting off slower and picking up and increasing faster and faster. So the question reads, when money is placed in a bank account that pays compound interest, the amount in the account grows exponentially. So that's important to note. That tells us what kind of function we're looking for. Suppose such a bank account grows from $1,000 Canadian to 1,316 Canadian in 7 years. Okay, so let's look at some of the information we have. So we know that it started at 1,000, and after 7 years it grew to 1,316. So at our time 0, at our beginning investment, it was 1,000, and 7 years later, the bank account had $1,316. So the question part A says find the growth function of the form, and it gives us this growth function. Okay, so if we're going to translate what this function is looking for, it's a function based on time, y sub 0. So sub 0 just means at your starting point. And so our starting point at time 0 is 1,000. So our y sub 0 is 1,000. B, I don't think we know B yet, and t we have as 7. So f at 7 is 1,316. Times 7, y sub 0 is 1,000. So the only thing we're trying to find that we don't have yet is b. So let's substitute the values we have and rearrange our equation to isolate b and see what b is equal to. So here we have 1,316 is equal to 1,000, b to the 7th. Okay, so b is in this exponent. We're going to have to see how we're going to get that b out of there. So the first thing we do is divide both sides by 1,000. So we have 1.316 is equal to b to the 7th. And if we remember some of our exponent rules, we're going to know that in order to isolate b, we're going to have to take the 7th root of this function. So for example, if you had the square root of x squared, that would equal x. The cube root of x cubed would equal x. The 7th root of x to the 7th would equal x. So you see the pattern? So here we'll just take the 7th root of this b to the 7th, which means we have to take the 7th root of the other side. So 7, the root of 1.316 is equal to the 7th root of b to the 7th. Okay, so on this side we have just b, and on the other side we have the 7th root of 1.316. Now again, if we remember this exponent rule, so the square root of x can also be written as x to the 1/2. The cube root of x can be written as x to the 1/3. These are equivalent. And so the 7th root of x could be written as x to the 1/7. Okay? So that's relevant here because we have the 7th root of 1.316. So this can also be written like this, 1.316 to the exponent 1/7. If we solve that, we will find that b is equal to 1.04. Okay, so let's see what our function looks like now. So we found that B was equal to 1.04. So now we can go back to our growth function and finish that off. So y sub 0 in this case was 1,000, and we have 1.04 is our b, and it's raised to some value of t. So now that we have this growth function, we're able to use it then to determine how much will be in the bank account so many years down the road, whatever number of years you're looking for. So in part B of this question, it asks how much is in the account after 12 years. So we're starting with 1,000, and we're going to be looking for how much is in the account after 12 years. So F at 12 is going to equal 1,000 times 1.04 raised to the 12th. Remember your order of operations. You're going to be doing this exponent first, 1.04 raised to the power of 12 times 1,000, and we'll find that the amount in the account is $1,601.03 after 12 years.